Okay, so the last set of practice problems were numbers 7 to 12. Number 7 asks you to find the radius of orbit associated with E5 and E6 in a hydrogen atom. So you're going to use this wonderful Bohr's wonderful equation, En is equal to h squared over 4 pi squared km squared, and then all of this gets divided by the n squared. So my recommendation when you're doing this would be like, so E5, because it asks for 5, will be equal to h 6.626 to the negative 34 joule seconds, and that gets squared, divided by 4 pi squared k 8.988 to the ninth Newton meters squared per k is in coulombs squared. No, kilograms squared. Sorry, I had to decide if I was doing kqq. No, it is coulomb squared. Sorry about that. Coulomb squared. M is 9.109 to the negative 31 kilograms. Q, that's because we're talking electrons here. 1.602 to the negative 19 coulombs, and that's squared. And then this whole thing, once you find it, will get divided or multiplied by 5 squared. So if I were you, I would find this number first, because then R6 is going to be that exact same number multiplied by 6 squared. So I would punch all of this into my calculator first and get that value so I wouldn't have to do it again. And it might take you a couple of tries, but you should get for this constant 5.292786028 meters. And then you're going to multiply that by 5 squared. And so when you do, the radius of the fifth orbital is 1.323196507, if you want to be exact, to the negative 9 meters. And then you're going to take that exact same number, 25927866028. Oh, I missed, really? Is it times 10 to the nothing? Okay, I wonder about that. No, it has to be times 10 to the negative 10. I think I just forgot to write that down in my question. Because you can't multiply that and get to the negative 9 otherwise. Times the 6 squared, and you should get 1.9045029 times 10 to the negative 9 meters. And this big constant is meters, because the 5 and the 6 don't have any units. But, oh, it's negative 11. Sorry, I knew I had saved it in my calculator. Negative 11. Negative 11. It might not be a bad thing, though, for you to see if you could prove the units there. That if you can get joule second squared on the top and all this jazz, and see if you can end up with meters. That should be fun for you, don't you think? All right. Number 8. Now the next ones, 8, 9, 10, 11 are all dependent on each other. And if you notice that before you began, your life would be easier. So in number 8, it wants you to find the energy levels from E2 to E6 for hydrogen. So you're going to use En is equal to negative 13.6 electron volts over n squared. So for n equals 2, this will be E2 is equal to negative 13.6 electron volts over 4 squared. And n equals 3 will be negative 13.6 electron volts. I did 4 squared, but it's really 2 squared. I was just squaring the 2 in my head as I was writing it down. 2 squared, or 4. And this will be 3 squared, or 9. So this one gives us negative 3.4 electron volts. This one gives us negative 1.51, and the one's repeating electron volts. N equals 4, E4, negative 13.6 electron volts over 4 squared, and it is negative 0.85 electron volts. E5 is negative 13.6 electron volts over 5 squared, which is negative 0.544 EVs. This is n equals 5. And n equals 6, E6, negative 13.6 electron volts over 6 squared, which is negative 0.37, and the 7's repeating. Okay, so that's number 8. And the reason I said they're connected is because now number 9 wants you to use all of these to find the difference in different energy levels. Okay, so there's 5 different parts to 9. And you're going to be doing for all of them like EP equals, so for 9A, it's 6 minus 5. So E6 minus E5. So that's negative 0.37 repeating minus a minus 0.544 electron volts. And you're going to get an EP of 0.162, and the 2's repeating and repeating, and it's negative because it's being emitted. It's going from higher to lower. Okay, but if you were smart, you would then go to number 10, because number 10 says, what's the frequency of this photon being given off? So 10A, you're going to use EP is equal to HF for all of 10, so F is equal to E over H. So it's going to be this, and you could drop the negative because the negative just meant emitted. So 0.1662 repeating electron volts. Got to change it to joules. So 1.602 to the negative 19 joules per electron volt divided by Planck's constant 626 to the negative 34 joules seconds. And you're going to get your frequency, which for 10A is 4.0188 to the 13th. Okay? And then you're going to use that to find lambda, because 11A wants to know, so what's the wavelength? So if I were you, I would do it all in one step so I wouldn't have to keep clearing. So we know lambda equals C over F. So 2.9979 to the 8th meters per second over the F you have in your calculator, 4.088 to the 13th hertz. And you get a lambda of 7.4596 to the negative 6 meters. Okay, so that's 9A, 10A, and 11A all done there. And then I would move to B, and it's going to be exactly the same procedure. So EP for B, it's going, jumping to, oh, it wasn't, it was going from 5 to 6, so it's not emitted, it's absorbed. This number's bigger, sorry about that. And this one's going from 3 to 6, so again it's going to be absorbed. So negative 0.37, the 7 repeating electron volts, minus a minus 1.51, 1 repeating electron volts. So EP will be 1.13, and the 3's repeating. And so then use that to find your F in exactly the same way. F is equal to EP over H. And I'm going to jump ahead here. Don't forget to multiply by the conversion factor. And you get an F of 2.740 to the 14th hertz. And then you go to lambda, and you get a lambda of, for the B, 1.0941 to the negative 6 meters. Okay, so this is the answer for 10B and 11B, and this is 9B. And then go to C and do the same thing. So C is 4 minus 2. And so it's negative 0.85 minus a minus 3.4. And so EP is equal to 2.55 electron volts.